Good evening, dear viewers. Welcome to the latest BH Futures webinar. Tonight's title of webinar is A Journey in Aerospace. Our honorable speaker, Muhammad Imran, is an aerospace engineer with masters in chartered engineering. He is currently working as a program manager with Boeing. Imran has gained an extensive experience in aerospace through working with some bigger aerospace companies and airlines. Imran has been involved in some amazing projects like developing flying cars and the project Oranje, about which he will hopefully tell us later on. At this moment, I would like to say thank you so much for being here with us today, and please tell us about your journey in aerospace.
Thank you very much, Ahmed, and it's an honor to be here. You guys invited me to, it's an honor for me, and I think it's a privilege to share my experience at this forum. And as one of your colleagues, put on LinkedIn that I will teach you from aerospace, and I think as for the teaching or learning goes, I will be learning from this forum. The way you guys put this all together, and all those webinars, and you guys are doing a noble job. So I will be just sharing, and I will be the learning from the one learning from you guys. So the presentation I have put together, about 19 slides. We start with introduction, life journey, a little bit of education background, and a professional experience working in different companies, and then we will talk about a little bit more in aerospace, what aerospace is, basically, a few things, few facts, and then opportunities in aerospace, basically, what the opportunities we have, what aerospace can offer, and how you can join aerospace. So first of all, so this is I just told you the agenda, introduction and life journey. The next one is the life journey. This is my life journey, all dotted in blue. That's where I have lived, basically, in different part of the world. I was born in Pakistan, and I was a baby. I was a child when we moved to Turkey, because my dad, he used to work on a ship. He was a traveler. We went to Turkey, lived there for a while. Then we went to Germany, because that's my dad was working originally, actually. So we lived there, and I joined the kindergarten, and then I moved back to Pakistan. Did my basic education there, and then we moved to Holland, because my father then, by that time, had moved to Amsterdam. So that's where I finished my basically high school, college, and university. I did my aerospace engineering from Technical University of Amsterdam. After a while, when I was working, and then I moved to UK, then I moved to USA, came back to UK, then I found another job, Aeromobile in Slovakia. So I was in Slovakia for 2 years, and then I moved back to UK. So currently I'm in UK. So that's my life journey. It's good to see that, because moving around the globe, different countries, different continent, it developed my personality, my career as well, because I didn't want to bound my career in the boundaries. Like, there were not many opportunities for aerospace wise in Amsterdam or in Holland. There are more opportunities in UK, a lot more opportunities in the US, but that's why I for career development, I moved quite a lot. Education wise, I did my bachelor's from excuse me. I was just recovering from COVID, so excuse me if I'm coughing a little bit. I did my bachelor's from Technical University of Amsterdam. But beside that, I was working part-time as well. And after I did my thesis with the Royal Dutch Air Force, which was quite a privilege. It was a really good project. And after getting my degree, I started working for KLM. For a few years, And I did my master's professional engineering. Actually, that was a chartered engineering I did while I was working in the UK. That was not a full-time study; it was a part-time study. So I was working all the. I will go more in details when I will be talking about GK and Aerospace. And that time I was working, and the whole study was around my current projects. So that was a distance study, but it helped me a lot, career progression, and and made me understand a little bit more a different aspect of engineering and also the management. So that's my educational background. Not much. I didn't do any PhD, but that's all. Professional experience. When I finished my bachelor's, I started working for KLM. I joined as a planning engineer for wide body aircraft. Wide body aircraft is 747 or 777. Wide body is when you have two aisles. 737 and A320, they are single aisle, so they are named as a twin aisle or narrow body. Bigger aircraft, bigger jets, 747, 777, 767, 787. They're all wide body. So we were doing the wide body maintenance. In aerospace, in airline business, for example, when you have there are different checks for the aircraft. When you land at the airport, they have a dispatch or a line check. They are very small checks. They check the entire aircraft for any cracks or stuff like that, or any other parts. Then you have a C check. C check is about 1 week, 2 weeks. As you know, that in aerospace, in an aircraft, all the parts they when they install, the flight hours and the flight cycles are monitored, because all the parts, when you see in airline business, they for example, if you have installed a wheel, for example, how many flight hours he has done and how many cycles he has done. Flight hours is very simple, that you know how many hours it was in the air, and flight cycle is when you take off and land once. That's flight cycle. So all the parts they go along with it, and some of the parts they will be changed during this some checks based on their flight hours made. So some of the parts will be changed. A check and C check. D check is the heaviest maintenance check of the aircraft. During the D check, all the parts they come off of the airplane, in engines to landing gear, the seats, everything. Even the paint is stripped off. So it's just the airframe, just the body with aluminium, just a plain body that's left. And then they start building that again, all the parts overhauled or new parts, or after repair they will start going back. And within 4 weeks, the first day comes in till he flies back. It takes about 4 weeks. Some airlines they do, in MROs they do 3 weeks as well, but the D check is mainly 4 weeks. But if you have any question, we can answer later, but I will go more maybe in details. So that's the heaviest change. That's what I worked for KLM for a few years. Then KLM was bought by Air France, and then I thought it's time for me to make a move. And then I found a project job in the States. So I was there as a project manager, SNS engineering, for just over 1 year. Came back to UK. I joined GK and Aerospace. GK and Aerospace is a quite big company. They make everything. They make cockpit windows, rotor blades. They have engine shop. They have flight services. It is quite a big company. I spent about 5 years, I think. Yeah, 5 years in GK and Aerospace. Started as a development engineer and worked to a project development manager, which is quite good. You get your own project and you develop all. For example, cockpit windows, you see the windows is just made of glass, but it's not a glass to see through. It's a whole system on its own. You have different layers. You have one layer of glass, one interlayer, and then glass again, and interlayer. So for example, for 747, you have 3 layers of glass, and between you have 2 or 3 layers of interlayer, which is transparent. You can see through. Main thing is to hold the foreign objects outside. It's not just the temperature difference, because when you're flying about 50,000 feet, 57,000 feet, you have -50, -55 outside, and inside cabin temperature is around, ambient temperature, 22 degrees. So that temperature needs to be held, and the pressure, because when you fly, you can feel that when you take off, cabin is pressurized outside at 50,000 feet is different to inside. So that pressure need to be held. If the glass is broken, you might have seen in the movies when you have a hole in the aircraft or something, then everything is sucked up outside, and the aircraft fall into pieces. So that's why the window is very important. Also, the bird strike. Most of the bird strike during the takeoff or landing, they happen that hit the window. Glass is broken. Outside glass can be broken, which is fine. But then even all the glass is broken, the window need to hold the pressure. So that's the main task. So we do all the different testing, fail-safe tests, pressure test, bird strike test. We even, during the manufacturing, we made a window, we tested, fit the window on aircraft, and we shoot a bird at the speed of an aircraft. For example, hail strike test, rain test, sand, there are all lot of testing to be done before you fit the window on aircraft. Actually, any part need to be fitted or installed on the aircraft need to go through a series of testing for qualification. So I did for a few years, and then also part of GCAN. I was part of the integration team when GCAN bought Fokker. Maybe Fokker used to make aircraft, and it's a Holland-based company. They had a quite a big company for Fokker services, landing gear, and aircraft wiring and structures. GCAN bought Fokker, and they paid about 900 million euros. So a team of GCAN Aerospace, because GCAN Aerospace about 50,000 people all around the world. It's a British company, so we went a team of 20 to take over or integrate between GCAN and Fokker. So it was a 6-month project, and I was flying every Friday back home, and then Sunday I was flying, or Monday morning I was flying back to Amsterdam. It was a quite good project. It was called Project Oranje, but it was quite good project to be part of. When I came back after that project, I got a job offer from Aeromobile in Slovakia. They were developing flying cars, and they already had 2 prototypes before. They made in the garage or something, but now they were moving as a company, and they needed someone to move forward. So the management team was based mostly outside Slovakia. I was a project development manager for aerospace side, because that car, that vehicle need to be a car, so you can drive it, on the road as a normal car. And also, when you press a button on an airfield, it will convert into an aircraft. If you search Aeromobile on online, you will see those videos. So basically, it's like a fly. The wings are folded back on the top of the vehicle. You press the button, but you have to be on an airfield or airstrip, and then the wings open up all the way, and it converted to a lightweight aircraft, and then you can fly. Only thing you need is basically, private pilot license, and you can fly up to 3,000 feet. Top speed was on the road was, I think, 260, and you can take off with 110, 120 miles an hour. And it was a petrol engine. On the wings, you had those solar panels. So when you're driving, you can drive electric, and then you can fly up to 3 hours, 3.5 hours, 850 miles. I think 850 kilometers was the range. It was quite good. I spent 2 years working for them. I was preparing all the testing for the new model. I bought all the instruments, flight testing. It was about 170 different instruments we bought to be installed on the vehicle when you are flying for the test flight, because you have to monitor everything. You have to record everything to show for the qualifications that you can sell as an aircraft. And I spent 2 years flying back and forth from UK to Slovakia away from the family. So eventually I decided, okay, I had enough experience, so I stopped. And then I started working for Mirror's Aircraft Seating just over 1 year because yeah, basically they make aircraft seats. And then I got a job offer from Boeing Global Services as a program manager, and just 2 years now, then I'm working for Boeing as a program manager, managing programs for modification. The airlines or the leaser companies, they come to us if they want to modify an aircraft interior from nose to tail, everything inside, also avionics. And then we give them a timeline and we discuss it, timeline, and then we finish the project. The project can be as small as 3 months project to 2.5 years, 3 years project. Currently, I'm working on a couple of big projects. You have smaller projects and big projects. The biggest project at the moment with me is the Qatar Airbase. They bought 30 new 787s, and I have finished one project modifying their business class for 7 aircrafts, and now the remaining 23 aircrafts, that project is still ongoing. That's why I was traveling a lot for them as well. Quite a good job, good company, and we will go more in details for a Boeing in few minutes. I think next one. Excuse me. So Boeing is a quite big company, as you know. As a student, when you are in the uni studying aerospace engineer, your dream job, your dream company is Boeing. Nothing is above that. After that, you have some other companies like General Electric or Rolls-Royce making engines, or Airbus or something, but Boeing is the number one, and it was my dream job as well. Yeah, but unfortunately, I didn't get at that point, because freshly from the uni, they all want to have some experience. So I went on my experience with a different company. Finally, I'm here. Boeing, big company. They do quite a lot of things. Boeing Commercial is BCA. That's the part of the company. They make new aircraft. All the new aircraft are made under BCA, and they have lines in Seattle and all different part of the world. Main lines are in Seattle, and currently 787, 777X, even 767 UPS. So they are all made by BCA. We do have some interaction with it, but we will come back to that later. Second biggest part of Boeing is BDS, Boeing Defense. Sorry, I'm just talking. Boeing Commercial. So Boeing Commercial, they make all these aircrafts. They started from 707, 717, 727, old one, then 737, 747, the big one, the double decker, as 757, 67, 777, now it's 787. So now they are 2020, so they 787s. These are 787-7, -8, -9, and -10. 777X is not on that list. 777X is the latest, which has the folding wing. They can fold back and they can extend wings as well. So if they need a bigger lift, so they can extend it. So that's all the range of Boeing commercial aircrafts. And biggest seller was 737, as you all know. It's the biggest flown aircraft actually. Every airline has 737s. Boeing Defense, under Boeing Defense, all the military aircrafts and helicopters. Apache is one of them. Chinook, Apache is one of these. Lightweight aircraft, attack helicopter, A-10 wing replacement. Airborne, this is the early warning control system. This is 737. It's also called wedge tail. Crew training systems. One Lancer, B-52 bomber, the bomber, C-17 Globemaster. Also, you can see in quite a few films. This is the Chinook and all those aircraft. This is also Apache. These aircrafts, this all Air Force related, and one of the biggest one is the Air Force One, presidential aircraft for a U.S. president. That's also made by Boeing Defense. And beside these, they also do satellites as well, the transport and military transport and goods transport, helicopters, and it's quite a big range. We do have some attraction with them, and we will tell you a bit later. And the final is Boeing Global Services, which is called BGS. That's the part I work for. Boeing Global Services. We do the modification and conversions for all commercial aircraft. Any commercial aircraft, we can do the modification, nose to tail, anything. Also, we do some work for BDS as well, for Boeing Defense, but that's minimum because they don't carry crew, and but that's very minimum. To do that work, we need to do. You need to have a high-level security check that need to be cleared, and then you can do BDS work. I have been security cleared last year for a couple of programs, but it's very very confidential. But that's our global services. We do all the modifications, interiors, avionics. Avionics, it's other word of electronic. All the electronics on aircraft, they are called avionics. Cabin safety is one of the main thing, one of the major thing. It's because aerospace and is all about safety. Because on the road, if something happened to your car, you can pull over to one side, and then but for if you're an aircraft and need to be safe, need to be 100% safe. Structures and new product development, these are the 5 departments inside our department. My job is as a program manager that I manage. If I get a program, for example, to modify the interior or avionics, then I get a team of the engineers and DE and a technical lead. Then I need to manage. I just manage them and the supplier and the customer. So, as a program manager, the main task is a firefighting, basically, troubleshooting, because every project is going well, and all of a sudden you come in the morning. You have issues with the customer. They want to change the work scope. They agreed, the contract, but they want something else. Suppliers issues, you name it. So that's how the program management job role works. But we will go in more details, I think, later. Aerospace. So what is the difference between aerospace and space? I don't know if someone is online or can answer it, but there's a very small difference between aerospace and space, and that is aero. Aero is air. So the difference between aerospace and space is the air. There is no air in the space. That's why there's some slight different configurations and different methods or different techniques applied to the spacecrafts, but majority is very similar to aerospace. If you can work on an airspace aircraft or helicopter, you can work on a space as well, because very similar. So aerospace currently global fleet is that's the figures from 2017. Currently, they are about just over 25,000 aircraft flying and growing 4% annually. And more than half of it, currently, there are more than 10,000 Boeing aircraft flying. So the remaining aircraft, there are Airbus, you have Fokker, you have Bombardier, you have Embraer. So all those smaller aircraft, but it's majority aircraft, they are Boeing fleet. And from 2017 to 2036, there will be, the forecast is 41,000, over 41,000 new aircraft are needed. 6.1 trillion market value, 6.3. And the traffic will be growing. That's the figures from 2007, 4.7 traffic growth. But as we know, because of the pandemic, that has slightly changed. We had a bad year last year. Last half year actually, but last 3-4 months, everything has kicked off, a lot more traffic, and we are also surprised to see that the aviation industry recovering that quickly, because of the pandemic. The biggest hit was taken by the aerospace industry, aviation industry, tourist industry. If you are an airline, you have aircraft. You want that aircraft in the air all the time. as much aircraft, is in the air making you money. If it's on the ground, it's costing you money. And for last year, for the pandemic, most of the aircraft fleet was on ground because they couldn't fly the passenger. No one was there to fly. And that's why a lot of airlines, they were a lot of in trouble. I know from Norwegian Air, they were in trouble. A lot of airlines, they were in trouble. And so they start using passenger aircraft for carry some cargo, medical cargo or other cargo, which is not allowed. But we did some projects. We just modify them, give them the paperwork, got them sorted. We did the courtesy for medical cargo. We did modification for free for the airlines, so they can take the medical cargo during that hard time. But that's what happened for the pandemic. But we were surprised that it has recovered very quickly. We were expecting this kind of recovery in end of 2022, 23, but it has recovered quite a lot. Still, it's not 100%, but it is still recovering. And fleet growth will be 3.5 between 2017 and 2030. The new aircraft delivery per region, you can see in North America over 8,600, Europe 7,500. Biggest delivery will be taken by Asia Pacific countries. China, Hong Kong, China is growing very fast. And they need a lot more aircraft. Aircrew will be a problem in a few years because there will be not enough airplane. There won't be enough aircrew, pilots, or air hostess. And China is building their own aircraft as well. So it's everything is booming in aerospace basically. And there's some more figures for the new aircraft. The wider body aircraft to wide body aircraft. The biggest market, it's 2,600 for the wide body 747 freighters, but the biggest is around that area. Medium, narrow body to wide body aircraft. This is 787. That's the biggest market. Fastest commercial aircraft, as you know, was just a question. We know that the military aircraft, they fly quite fast. I think if F-16 speed was 3,500 or something, 2 Mach. Fastest commercial aircraft is Air Force One, US presidential aircraft, which is 747 intercontinental. 747 is one of the largest commercial aircraft ever built. Okay, that's you have another Airbus as well, which is biggest, but this was the biggest one ever built. -8 intercontinental variant is the fastest, and it go up to Mach 0.86, which is equivalent to 659 miles per hour, which is quite fast. For some reason, they not as other 747, but this 747 an additional, very comprehensive and developed different engines and winglets, and they have all of the features. It's quite confidential as well, but that's the 747, the fastest one. So a little bit more about the aerospace. Aerospace. On the top, I have put a sketch of a gas turbine engine. That's the principle of working off a jet engine is very simple. If you, for example, you have a balloon, you blow up the balloon, and you let it go, it will just dance around and then fall off, because the air is exiting the exhaust through the hole very fast, and it's going around, making him move fast. It's the same principle here for the gas turbine. You have air inlet, the air goes into the inlet, and you have a compressor. Actually, it's 2 stages of compressor. The compressor job is to compress the air very fine, and then it will go through the combustion chamber where the fuel is injected. The high flammable fuel is injected and burned, when it's mixed with the air, compressed air, not normal air, compressed air, then it leaves, and then it drives the turbines at the back and leaves the exhaust with a very high velocity, very high speed, and that pushed the engine forward. And engines are attached to the aircraft, and they push the aircraft forward. That's simple. Okay, you have a lot of different engines. Some of the engines you have the bypass ratios. The air goes in, and 10% of the air is uncompressed, bypassed, and added in the exhaust directly. So 90% goes through is compressed and go through the combustion. 10% go directly through to the exhaust, which give them an extra edge. It will, because of the difference of the compressed air and non-compressed air, it makes it more faster. That not all the engines have that capability, but the new engines they have. So that's the basic principle of the engine, gas turbine engine. Principle of flying, very simple. You have engine on the aircraft, which is pushing forward, which is also called thrust. Obviously, because you have air, you have a drag, the friction, and the wings, they create the lift, so the aircraft can stay in the air, and you have the gravity. So they are the four main forces on the aircraft, and that's how you fly it. So you create more thrust and the lift to stay in the air. Going more in details of the flight controls, as you know, thrust. So aircraft in the car, you have control. You move forward, or you turn left, or you turn right. Those are your movements. You can go back as well, but you know that's the main your moves. But when you are flying an aircraft, you have you're moving forward anyway. But the flight controls, you can roll. Imagine you're going on the straight line, but then you are rolling. Like you can see some aircraft, military aircraft, for example, they roll fast to to make the maneuver. So that's roll. And the second movement is yaw. So you're in a straight line, but then you are moving left or right, for example. So that's the yaw. And the pitch is going up or going down. So that's all three different controls. And to make that happen, it's very simple principle, like you have in the car. Again, you have the steering wheel. Steering wheel is connected through your axle to the wheels. When you turn to the left, that wire, the metallic wire, just turn it around. It's very simple principle, but it's a bit more complicated, but simple, as simple as that. You have the wires, you have mechanics, metal rods connected to each other. So imagine you are sitting here, that's your cockpit pilot seat. This is your control, that's called yoke, or you have the joysticks these days, and this is your seat. To make the aircraft turn left or right, you have to pedal left. So if you want to turn left, you press the pedal on your feet left. If you want to turn right, you press the pedal under your feet, on the right feet. And these pedals, they are connected to the rudder, and rudder basically is in the tail. When is, for example, that rudder, you want to turn to left, it will move to this one move to the right, and then the air will push you to the left. And if you want to move to the right, you press the right pedal, and it will turn other way around, and then you move to the right. Simple. And roll is, again, you have the yoke. The roll is, just in a straight line moving like that. So that is controlled by, you have flaps, spoiler, and ailerons on the aircraft wing, and you just turn the yoke, to the left, and then you will turning your aircraft to the right, because the yoke will mechanically connect it to the ailerons and the aircraft flaps on the wing, and then they just turn left, up and down, because if they turn left, it means that air is coming through there, it will be touching it down, and then it will be moving aircraft to the rolling to the right. And it same goes for the pitch. When the pitch is going up and down, nose up and nose down, because it's very important when you are landing, the big jets are landing their nose up, they touch down with the main landing gear first, and then they go the nose down. So that is controlled by the elevators at the back of the tail. And again, that's done with the yoke. You push him down, goes down, and you push him towards you. The yoke is here, the kind of steering wheel in the aircraft. You push him up, nose up, and the aircraft goes up. And the yoke controls the elevators. Push him down. Imagine you are going like that. And at the back, aileron is pushed down. More friction for the air. Push him down, and the nose goes up. Very, very simple principles, but the mechanics behind is a bit more complicated. That's basically is the aerospace. Opportunities in aerospace. Oh, by the way, any question, please ask me a question later. Opportunities in aerospace. There's a lot of happening in aerospace. You have aerospace manufacturing, parts and spares suppliers. You have airlines. You have regular bodies. So the aerospace manufacturing, you have a big companies, they manufacture aircraft, basically like Boeing, Airbus, Embraer, Bombardier. You have Gulfstream. You have you have all, and then you have a military aircraft as well. And in the region where you are, the Bosnia Herzegovina and Czech Republic, Ukraine, that region, that's very rich for the smaller aircraft. You have a lot of small companies, they are manufacturing smaller aircraft there. That's the aerospace aircraft manufacturing, basically. You can build your own airplane at home as well, which is very funny, but you can. You can get an engine, motorcycle engine, or your car engine, whatever. You can build your own aircraft in your garage. But you can fly. You cannot fly. If you have a working aircraft that you think you can fly, to fly that, you need a permission from your local CEA, so local civil aviation authority. Every country has their own civil aviation authority, so you need a permission to that. And to get the permission, you need to show them that aircraft is airworthy. And to show that, when you are building an aircraft, you have to build it's called a build log, a book. Every part you have bought or made, you have to write it down. How do you get that part? You have bought a material, you have bought an engine, or you have bought some, I don't know, a tape. You have to write it down. If you have a bill, very fine, you just add that bill into it, or delivery note, or what material that is. And when you're screwing it together, putting it together, installing it, you write it down step by step. How did you do it? And that build log goes to the Civil Aviation Authority. They will review it, and then they will grant you if they are satisfied, they will grant you a flight permission. Then you can fly the airplane. That's for that one flight only. If you have applied a permit for example, 2 flights, probably they will grant you, but you can't fly any more than that. But if you want to go more, okay, you are satisfied, you have got, given them the build log, and they are happy, and you landed safely, and you want to go manufacture it and sell it, that is another story. You have to show them, because every part you install, that need to be shown that is certified part, that is qualified part, and is airworthiness safe, for to be flying. So that's all it. Basically, you can build an own aircraft in your garage. Parts and spare supplier, you have plenty of parts going in the aircraft. Wires to engine, even the engine has hundreds of parts, and then all those parts, you can supply those parts, you can work for them. Give an example. If you have you need a screw for your, I don't know, to fix your bathroom or your furniture, you go to a DIY, and then you buy that screw. It will probably cost you 50 cents. But the same company make a screw for a car or an automobile. When you buy that screw, it will cost you a lot more than that. It will probably cost you £1, or sorry, €1 or €2, because they have done some testing, or they have to fulfill the requirements of the automobile, that screw can be installed on that. So they have done some, the way they have the certification or something. So it will be a lot more expensive. But the same company manufacturing the screws or nuts or bolts for the aerospace, same company, it will be about £5, or sorry, €5 or maybe more, because they have to be they have to be done quite a lot of testing to certify that part to be installed. First of all, there need to be flammable flame testing. If you are using, for example, cars, your seat, passenger seat, you're using a cloth, need to be flame tested at certain level. It need to be toxic, not much smoke, and then it need to be. There's a lot of testing for every part. There are quite a lot of testing need to be done, so that part can be installed on an aircraft. For example, now we're working for GK and Aerospace. We were building those, manufacturing those cockpit windows. So that glass, need to flame test. All the material, even the sealer, need to be flame tested. All the testing need to be done. Fail-safe test, temperature test. Flame test, use bird strike test. You fly a bird at the window, and then every single part has its slightly different requirements, and that requirements are written by EASA or the regulatory authority, but you have to comply to them. And when you have done all the testing, then you submit all the paperwork to EASA, and then they will give you, okay, STC, you are authorized to manufacture these parts because these parts are safe. But you cannot manufacture part adding something new or doing something different you have been permitted to. Even if you change the process of manufacturing that, I need to go through the EASA again, because everything is written and you have to do exactly the same. Even if you, for example, using a tape or adhesive, just to bond something, if you are changing something, I need to go through it. That part is unqualified. If you use something that is not written in your paperwork and you have used that part or use it differently, that means that part is unqualified. It's a bogus part. If that part gets installed in an aircraft and then something happened, God forbid, something happened to the aircraft, then it might come down to that you have provided a bogus part. So it's a very strict industry, but it for the good reason, because we want everyone to be safe. Last is opportunities in the aerospace. First of all, you have aircraft manufacturer. Then we had parts manufacturers, airlines. You have all the airlines. Your big to small airlines. They all need, they need pilots. The ground, cabin crew. They need the ground crew to make that aircraft fly, and then they need maintenance crew to look after those aircraft. And they are quite big. In some airlines, they are that big that they do everything at home. Everything they do by themselves. Some of the, for example, Qatar Airways, for example, they manufacture their seat covers. They have a big setup in on their site that they are manufacturing those seat covers. Some seat cover the companies they do, but mostly they do by themselves. Carpets, for example, they buy the carpet and sew themselves, cut themselves. So they have good, and then C-checks, E-checks I just described in the beginning. They need a lot of engineering personnel to look after their aircraft. So it's quite big industry, and a really good industry to work with. working with aerospace is always fascinating for me as well. And then privilege for working with an airline is that you get some airlines, they give you then you can fly only paying 5% or 10% of the fare. Some airlines, they give you 10 tickets per year or 5 tickets per year for free for you and family. And I recall working with KLM that you only have to pay 5% when your family, mom and dad, they are flying. So it's a good industry to work for. And lastly, it's aerospace regulatory body. On the top, I have added EASA, European Aviation Safety Agency, which look after entire Europe. It's a European. Everything you are building or manufacturing or everything need to go through EASA. Okay, you can go to EASA or Federal Aviation Authority USA. It depends which certificate, but you need one of the certificate to fly. Even if you change something in the aircraft, you build something new, and need to be approved, it need to be certified, it need to be qualified. And EASA, they give you a certificate to fly. For example, my current project, we're installing a new business class seats in the airline. And because we are changing something, if you are changing some weight or structure in the aircraft, that need to go through them. So we are changing structure and we are changing the weight because the different seats. Everything need to go through EASA. When we finish all the testing and manufacturing and everything, and we will submit everything to EASA, they will grant us the papers, SB, service bulletin. And based on the service bulletin, we will install the seats, and then EASA will come and visit and they will inspect everything is done to that service bulletin. And when they are happy, then they will grant us the STC, which is a type certificate, so we can the aircraft can be flown. Otherwise, if they don't agree, aircraft will be on ground. Same goes for FAA, which is Federal Aviation Authority from US. They control mostly in North and South America, Central America. Most of the airlines, they have FAA validation, FAA and EASA, and also their local authorities as well. So I have down below here, I have civil aviation authorities, local is a British one, CAC, that's China, ANAC, I think it's Brazil. Okay, sorry, that was wrong. Bosnia Herzegovina is BHDCA, that's Bosnia Herzegovina Directorate Civil Aviation. I think this is Qatar, United Arab Emirates, Pakistan Civil Aviation Authority, Hong Kong, Australia. So these are all, this is the last one is Russia. So all the local authorities. Some few things you can, it can be certified under Civil Aviation Authority, you're local and you can fly. But then if you want to go through EASA, Europe, if you're flying to Europe, then they also need to be approved by EASA. So that's why these are two the main ones that that hold, the same. I think that was the last slide. And if I think, I don't know if I went too fast or too slow. I think if there's any question, I will be glad to answer.
Thank you so much, Imran. Now we will start with the Q&A. First question, what is the biggest challenge you have faced in your work?
Biggest challenge is, as I said, aerospace is basically about the safety as well, passenger safety. Challenge is to comply with the regulatory authorities, because you have so many different things going on, then you have to comply, and the things are changing as well. I can give you one example. When I was working for KLM, the D check, we had to install a part that was supposed to be repaired and overhauled, but the lead time was too long, so we bought a new part to install in the aircraft. Every new part comes with a certificate, but KLM has his own policy that need to be recertified internally with KLM, and that I was waiting for. But that was the last day of the check. Aircraft need to be flown away. At that point, the chief engineer who was doing the maintenance, he picked up the part from the stores and install it, and then he asked me to give me the certificate because it was a new part. It was no harm in that, but because it was not properly booked, so I went to him and said, no, it's not possible. So we called the QA, and it was a whole investigation, and then that part was uninstalled, and then it need to be recertified. So the main thing is, the answer to your question is sometime, because of the safety, the regulations and and specifications, they are so complex and so strict that you lose time, but you have to comply with it. So my biggest challenge is that to balance that between the time and comply with the regulations. Of course, you have to comply. It doesn't matter how long it takes.
Thank you. Next question is, how important are other occupations from STEM, excluding engineering, in the aerospace industry?
They're very important. I wanted to mention that in my presentation as well, that when I was discussing the opportunities, that you don't need to be an aerospace engineer to work in aerospace industry. You can be a mechanical engineer, because all the engineering are based on mechanical engineer. Mechanical engineer, you can specialize in go into aerospace. Electric engineer, you can work as electrical engineer in aerospace. You have HR, you have a legal body, you have IT, you name it. Everything. It's not that only you have to be aerospace and you have aerospace engineer to work with Boeing or any aerospace engineer. And I do respect all the other professionals, because I think which you haven't studied is always difficult. I studied aerospace engineering, and I think, I don't know why people, they say it's a rocket science. It's not rocket science. It's very simple. And I wouldn't understand, from a lawyer point of view, what he does. For me, it's very, very difficult. And also, as the same for the medical students, for example, they've been a doctor. Oh my God, how can it's very difficult for me. But I do respect all other professionals, and any profession can join aerospace.
Thank you. Next question. How important was your chartered engineering degree in your career?
Not very important. Not very important. I would suggest, if you have bachelor's, don't wait that you want to have a master's or chartered or PhD, so then you can start working, and you will be. Don't wait for that, because these days, I started after bachelor's, and I did chartered with them, and I was working for GKN Aerospace, and they paid for it. So when you can enter, when you have chance to enter an industry, just go for it. Start working with the company, and then go for the further education according to the company need and your need. That will develop your career even better, I think. Because if you, I'm not saying that don't go at all. It's up to you. But my experience is that a higher degree, very higher degree, is not essential to enter any industry.
Thank you. Next question is, what do you think about electric aircraft and the future of air travel in general?
Electric aircraft is coming. Flying car, it's not. We used to say it's future. It's not future. It's coming. It's a very the company I used to work for, Aeromobile, they have done their flight testing, I think recently, a couple of months ago. You have other flying cars company like Palvi in Holland. You have Lilium in Germany. They are all manufacturing. They are all coming, and they will be here soon. We see in the drones, they are already here. Electric is all the future, because fuel-wise, I was reading an article a long time ago, quite a few years ago, that we have used most of that, more than 75% of the fossil fuel already. That was about 10 years ago, 15 years ago. So the future is electric. Electric is going to take over, because we only need to, at this point, the current, the Aeromobile, we already had that solar panel on the wings to drive on electric. So electric is coming, and only problem challenge the electric industry is facing, so electrical car industry facing is the batteries that it can't give you a long life. 700, I think maximum is when I was in US last Tesla, there's 350 miles kilometer, or sorry, 350 miles to 400 miles. So it's just getting there. I think that is the future. And I was, like a renewable energy is the future. We are stepping away from the fossil fuel. We are going into renewable energy like wind farms, solar energy, and of course, electric is the future. Everything will be electric soon.
Thank you so much. Next question is, what changes have been implemented regarding the MKs on the 737 AC in order to be certified again? I hope
It's
I read
Max 737 Max you're talking about, right? Yeah, it's okay. It changes wise. I can't give you the details, but exactly changes because those changes are still ongoing. Aircraft. It's like IT. You keep developing stuff, and you can't stand still. Standing still is left behind. So you have to develop. 737 Max had a problem, had some issues, and those issues were resolved. And then after that, they become more political issues. So they have been resolved. And as you see that United start flying, United is one of our biggest 737 Max carrier, and they are flying biggest customer, and they place another order. So currently, I was reading the news, the Boeing news. That we have increase in 737 Max orders. We had whitetail. Okay, when a customer buys a plane, and then he decide not to go with it, we call that whitetail. They are just parked there, and then we will move on to the next customer. So we had a lot of whitetail aircraft parked in Seattle because of the pandemic. They couldn't go, and those whitetail, they have been moved around now, and most of them, they were 737, and they are going and they are flying. United, based on on when they made those changes to 737 Max, and they did the test flights, and United start flying, and based on that decision, they have placed another order. So I can't go much in detail what exactly they change, but it is safe to fly 737 because it's the most flown aircraft.
All right, thank you so much. Next question is it possible to start working at Boeing Defense Systems after graduation?
Of course, I would recommend if you apply, because even when you are graduated, we have graduation schemes, we have even internships. So only thing you have to do is just go online and apply for that internship. You are intern, you will spend a few months, couple of months here with us in different departments. Couple of weeks with us in project management, few weeks in structures and avionics and everything, and then at the end, you have to give your opinion where you want to stay. Then you will finish your internship there, then you go back to uni. And then most of the people, I have seen a lot of people, they come back to Boeing. That was internship. And graduation, yes, of course, you can apply and you can work at straight off graduation, because what the big companies they do is, of course, they want to hire some experienced people as well, but they also know then when those experienced people come, they will gradually grow, and career progression, they will move on. But then when they hire something fresh from the university, fresh graduates, they will teach them. We have a good budget for the trainings and development, and those fresh graduates, they mold them how the company want them. For example, if you want to be as a PM like me, project management, they will send you all different departments, and finally you will end up in the department you want to work. And ideally, they have I can't tell you how many people, but they have a certain a budget and quota system that, okay, you can join as a fresh graduate. And I think it's ideal to start as a graduate.
Thank you so much. Our next question is, what would you say is the most important skill you need as a project development engineer in aerospace?
Main skill, as I would say it's a communication basically. As a PM project management, it's a communication because you are the interface of the company internally and externally. You are the focal point between the company and the customer and the supplier, and within the company, all different departments. Because currently I'm working in this position, I work with internally aircraft structures, interiors, avionics, sales, estimation team, supply chain. You have to manage them. So communication, and then also with the customer and supplier. So you are kind of a focal point, and you are the filter, because sometimes internally there are a lot of discussions that they're not happy with the customer, they're not happy with the supplier, but you have to filter that. You have to absorb that, and you can't reflect that to the customer or supplier. And same goes for the other way around as well, because suppliers or customer, they might be fed up with you. They want, okay, we wanted that 2 weeks ago, and why this part late, or why you are not holding on to this, why the drawing is late. So you have to absorb that, and you can't go and then start shouting at your engineering team, or you have to absorb that. And then that the communication is the one of the the skill that you will need. And I think teamwork, because everywhere you go, it's just a teamwork. You can't function on your own.
Thank you so much. Our next question is, what advice would you give to your younger self at the start of career, and what made you choose aerospace engineering at the beginning?
Okay, I will answer that second question first. I would say I didn't choose aerospace. Aerospace chose me. The reason for that is very funny. I didn't want to be. I never thought to be to join aerospace industry. When I was in high school, I wanted to be a captain on a ship. I wanted to study maritime engineering and progress through that, and wanted to be captain on the ship. That was my dream job. I, luckily or unluckily, I don't know, fortunately or unfortunately, I was on holidays after my high school, and I stayed a bit longer, came back. All the colleges, university, they started their courses, and I was looking, oh my God, I don't have anything to go. Only thing I can find was Dutch Aviation College, and they had an opening they were still looking for students, because they didn't close out their date for admissions. I said, okay, I will join that for 1 year. When after 1 year, because I have to show that I'm studying, at home. So I will study 1 year, and then I can change, because basically, as I told you, the mechanic is the basic. So you can study 1 year, and then after it's a 4-year study. You can study 1 year, and then after that you can change. But when I finished my first year, I liked it so much. No, I'm not going to change. I'll stick with aerospace, and I stuck with it. So I didn't choose aerospace. Aerospace kind of chose me. To my younger self, I would say, if I had the opportunity, even that time, I would say pay attention, because everything or anything they teach you at the college or uni, you are going to use it. You are going to need it in your future life, in your career, in your professional life. Because when I was studying, I said, oh my God, so big calculations, mechanics, and that, and aircraft engine performance, engine performance during the takeoff or landing. That was a humongous big calculation. When I am going to need it? But when I joined GK and Aerospace, my first assignment was to calculate a thickness of a plate to manufacture a pressure box to test the aircraft cockpit window. Just so you can install the aircraft window on that box, and that box will represent the cockpit. So that need aluminium thickness of that box. And I thought in the beginning, oh my God, that's thickness, how long will it take? But when I was given my manager told me, I have done that before a few times. Have a look at through. And that calculation was 21 pages to just to calculate that thickness. And then I realized, oh, I need it. So I first 3-4 weeks I spent just studying that calculation he did for a different aircraft. And after that, I started doing my own calculation. I did it in about 19 pages, two pages less than him. But then I realized that everything they teach at you at uni or college, you're gonna need it in your future life. So just pay attention.
Well, that is all for the questions for today's webinars. I just want to say that it was my honor, and I was really looking forward to hosting you today and listen to you. And I hope that you have an amazing day, and that there will be opportunities for us to hear from you soon.
Thank you very much, Ahmed. It was my pleasure to be here, and thanks a lot to giving me for giving me this opportunity to be here. And I really enjoyed it, and looking forward to see you too. And good luck with you, as in the foundation as well.